All right, everybody. Welcome to the video here for a brief overview of the Happy Birthday Polynomial project. So if you notice, this is for the Regents class. I am also posting this on the accelerated Google Classroom site. There is a couple differences between the two projects. In all honesty, they're almost the same, but there are some little things that make the accelerated one a bit more challenging. But this will at least give you a head start depending on whatever class you're in. So the first thing we have to do is we have to create our polynomial. Everybody's polynomial should be different, right? Everybody has either a different birthday, or even if you have a same birthday, the chances of you having the same birthday and the same favorite number are slim. So you're going to have some different stuff going on here, but the core premise of what we're doing is the same. Essentially, a lot of the steps are going to be the same. So I've created this polynomial with an a, a b, and a c, and a d as four different variables. Each variable is representing something from your birthday and or your favorite number. So my birthday is April 6, 1984. So the a value that I'm going to use is 4 because April is the 4th month. So I would put 4 here for a. I would then put 6 in for the day of the month I was born. And in 1984 ends with a 4. So I'd also have a 4 at the end. I would assume most of you at this point are born in 2001 or later, so we don't have to worry about zeros there. If you were born in 2000 and you're going to get a 0 for that last term, it's actually not a problem. It's just going to make it a little bit easier actually for you because you'd wind up seeing that your graph crosses at the origin. But we'll talk about that if that is you. Just come and see me. So my favorite number is 22, so I'm going to put in my d value of 22. By me specifically telling you this is your y-intercept. Since you know the y-intercept, you then can use that to find the value of k. Now here's where one of our differences is between the Regents class and the accelerated class. In the accelerated class, you have negative k. In the Regents class, you just have positive k. So if you're an accelerated kid, think about what that means and try and figure it out. Okay. So let's use my favorite number and my birthday to create this polynomial. So write your happy birthday polynomial below. So this should be where your birthday polynomial is. So this is mine. Notice have k in there. And my y-intercept is f of 0 equals 22. So again, that would be here for you. So let's figure out k. So to figure out k, I'm going to plug in 0 for all the x's and 22 for c of x. So I'm going to have 22 is equal to k times 0 plus k squared times 0 minus 6 cubed times 0 plus 4 to the 4th power. Now, if I type all those numbers and parentheses into my calculator here, right, so I'm still going to have this k, but I'm going to have this negative number, and I forgot my graphic calculator, but luckily Desmos has this nice little scientific calculator. Just graph desmos.com/scientific, and that comes up. So I have negative 884,736. Negative 884,736. I want to get k by itself, so I'll just divide both sides by that large number. And then I'm going to type this in my calculator. Now, depending on your birthday and your favorite number, well, you might not get a nice number here. Notice I typed my favorite number in and my value for my birthday, and I got this scientific notation number. Well, I don't want to use this number. I'd rather just leave the fraction. So I'm going to leave the fraction. I'm not even going to simplify it. It doesn't even matter because I'm going to wind up typing it in my calculator anyway when I graph it. So I'm going to just say my k value is negative 22 over 88,476. Now, the questions on the back can all be answered using the Desmos calculator, right? And I'm going to show you how to use the Desmos calculator now that we know our equation, okay? So to get to the Desmos calculator, we go to the internet and we type in desmos.com calculator, and this pops up. So I want to first start by making a parenthesis, same way you'd make a parenthesis if you were typing an essay or something like that. Type in negative 22 divided by is your slash mark next to the shift button, and that 884736 number, and then end your parenthesis. Then type in the rest of your birthday polynomial. So the rest of my birthday polynomial winds up being, was it plus minus plus? So I have x plus 4 to the second power. I have x minus 6 to the third power. And then I have x minus 4 to the fourth power. All right, that's my polynomial. Make sure, nope, it's plus 4 again. My bad. So it's plus 4 again, even though the minus 4 would be a cooler looking graph, but hey, we'll go with this one. Okay, so I don't see my whole graph. Problem, right? So how do I adjust that? So if you see up here in the top right corner, there's a little wrench. If you click on the wrench, well, that allows you to change your x-intercepts and your y-intercepts. Some of you with birthdays towards the end of the month, like if you were born on the 25th, you might have to change your x-axis, right? So you could just change the minimum and maximum values so you could see all your x-intercepts. Okay, that's all going to be determined by your birthday. For the y values, well, I'm going to start by making it negative 100. I look at my graph and I see I have way higher values above the x-axis. You might have way higher value or lower values below the x-axis. So I know I'm going to have to kind of make this a really big number. So I'm going to start by making it 1,000, right? So 1,000 is actually even too big. I can make mine probably just 100. So there's my graph, right? I could zoom in, zoom out. There's my graph. I don't know why I like tweaked that like that for a second. Okay. Now, if your graph doesn't show up, like say your graph was like you were born on April 22nd, well, you're gonna have this like giant graph, right? So you might have to change your window a little bit even more. So I know my x values are gonna have to go even higher and have to go up to like 30 so I could see that other x-intercept. And I could even just keep putting in numbers here. So 100, 1,000, 10,000, 100,000, and just keep adding a 0 there until you get a good view of what your graph looks like, right? And then you can kind of just print it out, right? So it all depends on what your birthday is, right? So that's kind of the nice thing about this. I'm really testing that you know what you're doing here because everybody has to do it different. So let's go back to my birthday here for a minute. So here's my birthday. We'll go back to my Zoom because I don't need all of this crazy stuff going on here. So we just go, so we just go 10, negative 10. I think I'm able to fit this in negative 100, positive 100. All right, so the other nice thing about Desmos is if you just click the line, all of the important points pop up. So if you just hover over them, that's an x-intercept, it's a y-intercept, that's a relative maximum, it's an x-intercept. So a lot of these questions on the back of the page, you might actually be able to answer just by looking at the Desmos graph, okay? So now that you have the Desmos graph done, you could print it. So to print it, you could just right-click and hit print. If you hit print, it'll pop up, loading, and you can print a nice version of what your graph looks like. Notice my print graph has all of the x-intercepts. It has all of the turns of my graph right? So we want to make sure you see on the entire graph, right, before you hit print. It'll even tell you what the equation is right on the bottom of the page when you print it out. Pretty cool, right? So once you've done that, you could then go back and start to look at all the other things that are asked on the back, okay? So again, some of these questions are a little bit different for accelerated, but just what are the zeros? What are the multiplicities? Use your notes if you have to, and then just take everything that you've done and put it on a piece of, you know, cardboard paper or construction paper or whatever you want to do there to present your birthday polynomial. Hopefully this video helped explain things. If you want to rewatch it or just take certain pieces of it or ask me questions next time I'm in school, just please let me know. All right. Best of luck. Hopefully you're having fun with your happy birthday polynomial project.